Okay, so we're going to be graphing linear relations today without any context behind them. We've worked with a lot of word problems so far in this unit. Today we're just going to be graphing the equations of lines. So let's talk about the format of the equations that we've been looking at so far and just give some labels and notation to it. Okay, so all of the graphs that we've seen so far, we've sort of started at like this starting value or a starting point. When we graph that, it's going to be the y-intercept or the vertical intercept. So here we see that this graph at x equals 0, the y-intercept is 3. In our equation, that is the number that is the constant term. That's where we start our graph. And then the term that is beside the variable, usually x, if there's no like word problem, that's going to be our slope or the rate at which our graph is changing. So for this graph, we see here that the slope is negative 1 over 2. Let me show you how we can see that. So the slope for every time, so if I look as I go from point to point here, as I go from this point to this point, see how I travel 1 increment down and then 2 to the right, and then 1 down and 2 to the right, 1 down and 2 to the right. So this is 1 down and 2 to the right. So the change in y over the change in x is what the slope is described as. Change in y, change in x. So that's how you figure out the slope. So we're going to practice doing that today and then graphing some equations. Okay. So let's graph this equation. It says example 1, graph and interpret a linear relation. First we're going to make a table of values and then we're going to graph this. This is the only time we're going to make a table of values. All the other equations we're going to just graph right from the equation, but the first time we'll do it with a table just so you can see where all the patterns are coming from. Okay, so if this is our equation and x is negative 2, to get the y value, I'm just going to write this out just this one time. To get the y value, I'm going to plug in negative 2 into the equation and evaluate it. So 2 times negative 2 minus 1, that's negative 5. So I get negative 5. If I plug negative 1 into the equation, 2 times negative 1 minus 1 is negative 3. 2 times 0 minus 1 is negative 1. And now we can already start to see a pattern forming. Every time here our y values are increasing by 2. If I plug in 1, I get 1. If I plug in 2, 2 times 2 minus 1 is 3, and 5. So if I look at the change in the y values, I'm always getting a plus 2, plus 2, plus 2, plus 2, plus 2. My coordinates of my points are just simply the x value and the y value, and these are the points that we're going to be plotting on the graph. Negative 1, negative 3, 0, negative 1, 1, 1, 2, 3, and 3, 5. Okay, so let's go ahead and plot that graph. So I'm just going to simply plot all of these values, all of these points here. So I'm going to start with negative 2, negative 5. So the first number is the x, the second number is the y. There we go. Negative 1, 3, negative 3. There we go. 0, negative 1, 1, 1, 2, 3, 3, 5. And if I had a nice ruler, I would draw a nice straight line between these points, but I'm just going to do my best. Oh, that's not too bad. Okay, there we go. So there's our nice line, and let's look at a couple of things here. So just above here, I labeled the y-intercept and the slope. Let's look at what the slope and the y-intercept are for this graph. So the y-intercept here is negative 1. That's the value we get when we plug in 0. It's like the starting point of the graph. So the y-intercept here is at negative 1. And the slope is what happened, like how is this graph changing over time? What's the rate of increase? So every time I go up for point to point, I'll go up by 2 and over by 1. up by 2, over by 1, up by 2, over by 1. So the slope is going to be, it's always the change in y over, oops, I can notice here that I'm off the screen with that little explanation. So the slope is always the change in y, I'll write it over here, over the change in x. For this graph, we're going up by 2, over by 1. So it'd be 2 over 1, or just simply 2. Okay, so that's our slope. So our y-intercept is 1, and our slope is 2. I'm keeping all the colors consistent here for you. It says use the graph now to estimate the y value when x is -3. So we can see that on the graph at -3, the y value is going to be -7. Right here, I'm going to label this point. If that pattern continues. Okay, use the graph to estimate the value of x when y is 7. Okay, so here's y is 7. Let's look over at the graph. The value of x is going to be 4. Okay, great. Now let's practice graphing a little bit more quickly now that we understand some of the patterns. I'm just going to reiterate one more time. The number that goes in front of the variable is going to be your slope or your rate of change. And then the number that's by itself, the constant term, is the starting point or the y-intercept. Those are going to be the two values that we're going to use to graph the equations. Okay, so let's graph these linear relations here. I'm going to highlight my terms that I was highlighting before. So the starting point or the y-intercept for us is going to be -2, and then my slope is going to be 3. Always start with the y-intercept. It's called the starting point for a reason. Okay, we're going to start there at -2. I'm going to highlight that. And then I'm going to use the slope to graph some more points. So the slope here is 3, which can be thought of as 3 over 1. So this is the change in y. This is the change in x. So I'm going to go up 3 and over to the right 1. Always go in the direction that you read. So I'm going to go 3 up, 1, 2, 3, over 1, and put a point. Up 3, over 1, put a point. Up 3, over 1, put a point. You can also go backwards, 1, 2, 3 down, and 1 to the left to continue the pattern. So there is my graph that has a slope of 3, because we're going up 3 and over to the right 1, up 3, over 1, every single time. Okay, let's try this one. This one doesn't have a constant term, which is a little bit strange, so we'll talk about what that means. And it has a slope of -3 over 4. Sorry, I forgot to highlight these two. Okay, so my y-intercept, if there's nothing written there, that means there technically is a 0 there, but you just wouldn't write +0. So the y-intercept is going to be 0 this time. Let's start with that. And then my slope is negative this time, -3 over 4. That means change in y is 3. It's going to go 3 down and 4 to the right. Change in x. Okay, so I'm going to count 3 down, 1, 2, 3, and 4 to the right. 1, 2, 3, 4, and put a point. And I'll do one more. 1, 2, 3, 1, 2, 3. I'm a little bit off the screen, but that's okay. And then I'll go, you can go backwards as well. You can go 4 to the left, 1, 2, 3, 4, and 3 up, 1, 2, 3 to continue the pattern. And we'll draw a nice straight line, hopefully, yeah, between those points. There we go. Okay, so my slope and my y-intercept. So start with the y-intercept and then count out the slope. And when you start doing your slope, always go in the order that you read. So that's what I always tell students. So if it's negative, you're counting down and to the right. If it's positive, you're counting up and to the right. Okay, let's look at these two interesting scenarios. These are kind of special cases. We don't have a slope really for either of these. So x equals 4. This is going to be a straight line, but the x value for this line is always going to be 4. The slope is actually undefined for this. equation, but it is a straight line, so I do want to talk about it. Think for a second what a line might look like where the x values are always 4. So let's find x equals 4 on the graph. Every single point, let's start plotting some points where x equals 4. This point has x equals 4, this point, this point, this point, this point, this point, this point, and then all these points as well. All these points on this vertical line all have an x value of 4. So the line is going to be, this is going to be a vertical line. For vertical lines, the slope is actually undefined. The reason for that is because normally you do change in y over change in x. Oh, I'm just noticing a typo I made on here. I put change in y. And if you're the change in x here is 0, so if you're dividing by 0, it's an undefined value. Okay, and let's look at this one. Y is -3. So let's try and plot all the points where y is equal to -3. So y equals -3 is right here. And then all of these points would also have a y value of -3. So it is a straight line. It's kind of a special straight line. And for this, the slope is 0 because the change in the y values is 0. So this is a horizontal line. And the slope is 0. You could think of this equation as y equals -3 plus 0x. So the slope here would be essentially 0. You just wouldn't really write the 0 term. That's why it's not shown. All right, that is the end of the lesson.